Welcome students. In this lecture, we are going to learn about the application of Cauchy's residue theorem to evaluate real integrals, contour integration, unit circle. This type is of the form integral 0 to pi, 0 to 2 pi, f of cos theta, comma sin theta into d theta. This integration will be of the form integral 0 to 2 pi f of cos theta comma sin theta into d theta. Here, this integration is in the unit circle. Why we are saying it is in the unit circle? That we are going to see it now. First, we have to convert this theta in terms of complex variable z. For the conversion, we are taking the transformation z equal to e power I theta. This gives you the derivative of z is I into e power I theta into d theta. What is e power I theta? Z. So you can put Iz into d theta. Now d theta is equal to, bring this Iz to the side. Therefore you will get 1 by Iz into dz. Next, we know that what is z equal to e power I theta by Euler's theorem cos theta plus I sin theta. We are going to express cos theta in terms of e power I theta and e power minus I theta. So e power minus I theta is what? Cos theta minus I sin theta. This e power I theta is representing as z. Therefore, e power minus I theta will be 1 by z. So by adding, if I am taking this equation as 1 and this equation as 2, by adding 1 and 2, addition of 1 and 2, you will get 2 times of cos theta equal to z plus 1 by z, or cos theta equal to 1 by 2 times of z plus 1 by z. To get sin theta value, we are going to subtract 1 and 2. By doing the subtraction, sin theta equal to 1 by 2i, z minus 1 by z you will take. Now take LCM, you will get cos theta equal to z square plus 1 divided by 2az, and sin theta equal to z square minus 1 by 2 times I times z. So you can see that the type is given as what? F of cos theta and sin theta, that is function of cos and sin. That function of cos and sin can be converted into the complex variable z. So here we have taken the assumption as z equal to e power I theta. Okay. So here z equal to e power I theta. Therefore, we know that this unit circle angle is what? 0 to 2 pi. This angle is 0 to 2 pi. It represents the unit circle mod z equal to 1. That is a circle with center 0, 0 and radius is 1. Okay. So because of that only, we are calling this as evaluation of the integration over the unit circle. Now after converting this function cos and sin theta in terms of z, you can use Cauchy's residue theorem. How? This will become a function of z. So you will have this equal to, okay, integral over the contour C, okay, f of z into dz, which can be written as 2 pi I into sum of the residues. Here C is the unit circle mod z equal to 1. So please keep these formulas in your mind put z equal to e power I theta, then dz will become I e power I theta into d theta. After that, you have to know what is cos theta in terms of z. It is z square plus 1 by 2z. Sin theta equal to z square minus 1 by 2iz. Substitute in the function, then the function will become in terms of z, that you can evaluate by making use of Cauchy's residue theorem. Now see this example. Evaluate integral 0 to 2 pi d theta by 5 plus 3 cos theta. So what is the conversion? Z equal to e power I theta. Then dz will become iz into d theta. So d theta, you are writing dz by iz. Now cos theta equal to z square plus 1 divided by 2z. Sin theta equal to z square minus 1 divided by 2iz. Substitute everything. So cos theta equal to z square plus 1 divided by 2z into d theta, you are going to put dz by iz. So doing the simplification, you are going to take LCM. Therefore, 10z here, this will become 10 plus 3 into z square plus 1 divided by z, okay, into 1 by 2. So this equal to 10z plus 10z plus 3z square plus 3 whole thing divided by 2. So bring this 2 to the numerator. You will get and one more thing, you are having I here. So and 2z also you are going to get, because here you are having z. We have taken it common. So 2z. Therefore, this z and z gets cancelled. You are going to have 2 divided by, okay, 10z plus 3z square plus 3 into dz divided by I times z into z. By taking this 2z to the numerator, this zz gets cancelled. So you are having 2 by I integral over the contour C dz divided by, okay, rewriting in terms of the highest term first, 3z square plus 10z plus 3. So here f of z equal to what? 1 by 3z square plus 10z plus 3. This can be evaluated by making use of Cauchy's residue theorem. By Cauchy residue theorem, this integral over C f of z into dz equal to 2 pi a into sum of the residues of f of z. So for finding the residues of f of z, you have to know what are the poles. So first, we'll write it out. Here, we are having f of z equal to, that is 3z square plus 10z plus 3. We have to do the factorization. By doing the factorization, what you will get? Minus b plus or minus root of b square. So here minus 10 plus or minus plus or minus root of b square is 100 minus 4 into a is 3 into c, 4ac divided by 2 times a. So it is equal to minus 10 plus or minus 100 into 4 3s are 12, 12 3s are 36. So under root of 64 divided by 2 into 3 is 6. This gives you minus 10 plus or minus 8 divided by 6. So it is going to be minus 10 plus 8 divided by 6 and okay minus 10 minus 8 divided by 6. So the 2 points are minus 2 by 6 and minus 18 by 6. Okay, by doing the simplification again, we are going to have the z point as minus 1 by 3 and okay, my z equal to minus 3. Now, we have to observe that the circle here given as mod z equal to 1, unit circle. Okay, so unit circle means circle with center 0, 0 and radius is 1. So now, here the point z equal to minus 1 by 3, where it lies somewhere here. Okay, z equal to minus 1 by 3. What about z equal to minus 3? Z equal to minus 3 lies here. Okay, so the point z equal to minus 1 by 3 lies inside the circle mod z equal to 1, and whereas the point z equal to minus 3 lies outside the circle mod z equal to 1. Therefore, you have to find out the residue. Okay, so I can say that z equal to minus 1 by 3 is a pole of water what? Is a simple pole, lies inside, okay, lies inside mod z equal to 1. And z equal to minus 3 is a pole, z equal to minus 3 lies outside mod z equal to 1. Therefore, you have to find out the residue at the pole which lies inside mod z equal to 1. So, you are going to find out the residue. It is a simple pole. So, the formula is what? Limit z tends to minus 1 by 3. Z minus, z minus of minus 1 by 3 will give you z plus 1 by 3 into, okay, f of z. What is f of z here? F of z equal to 1 by, we have considered f of z equal to 1 divided by 3z square plus 10z plus 3. So, you have to put f of z here. Why they have put it like this? We know that z equal to, okay, here f of z equal to 1 by 3z square plus 10z plus 3. Okay, now 3z square plus 10z plus 3, we can write it as what? Z minus of minus 1 by 3. So, z plus 1 by 3 into what? Into z, okay, z plus 3. Z equal to minus 1 by 3 and z equal to minus 3 are the singular points. So that we are writing it as z minus of a, okay, format. So z minus of minus 1 by 3 is z plus 1 by 3 into z minus of minus 3 will give you z plus 3. Then how they are getting like this? You may get confusion. So here, to get in this manner, since the coefficient of z square is 3, you have to multiply these, okay, factors by the coefficient of z square. Otherwise, okay, you won't get this equation. This equation should be equal to na. If you are not writing, okay, if you are not putting 3 here, if you are not putting 3 here, you won't get, okay, you won't get 3z square plus 10z plus 3. Okay, because here you are having 1 by 3 na. By taking LCM, you will get 3 in the denominator. So, to remove the 3, you have to multiply it by 3. Or, in a simple manner for understanding purpose, if the coefficient of highest power of the polynomial is 1, no need to put any number. If the coefficient of highest power of the polynomial is having some greater than 1 coefficient, you have to multiply it by that. Okay, so this gives you 3z plus 1 into z plus 3. Because of that only, they are writing f of z equal to 1 by 3z square plus 10z plus 3 as 1 by 3z plus 1 into z plus 3. Hope you understood. Okay, now you have to apply z tends to minus 1 by 3 now. Z tends to minus 1 by 3. See here, you can write it in this manner, or you can simply put 3 times of z plus 1 by 3 into z plus 3. Both are same. So this equal to this one. Now cancelling the z plus 1 by 3 common term, you will get, okay, 1 by 1 divided by limit z tends to minus 1 by 3, okay, 1 divided by 3 into z plus 3. Now put z tends to minus 1 by 3, you will get 1 by 3 into, okay, minus 1 by 3 plus 3. So which is equal to 1 by 3 into, take LCM, you will get 9 minus 1 will give you 8 by 3. So 3 gets cancelled, you are getting 1 by 8. Okay, if it is confusing for you, no need to write it in this manner. Okay, you can skip this step. Instead of writing in this manner, you can put, okay, 3 into, see the factors, 3 into the factors, z plus 1 by 3 into z plus 3. So z plus 1 by 3 you can cancel it off, common factors, and put z tends to minus 1 by 3, you will get the answer as 1 by 8. Now we have found out the residue at z equal to minus 1 by 3. So substitute in the formula. What is the formula? We are having already 2 by I is in the is from the integration function. When you are converting in terms of z, it is coming like 2 by I. So 2 by I into 2 pi I into sum of the residues of f of z as per Cauchy's residue theorem. Okay, so here I gets cancelled. You are getting 4 pi into sum of the residues of f of z, that is at z equal to minus 1 by 3, you are getting 1 by 8. So putting 4 pi into 1 by 8 gives you pi by 2. Hope you understood the problem. This is a important problem in application of contour integration. So first you have to take z equal to e power I theta and replace all cos theta d theta and convert the integration in terms of z, then solve it with the help of Cauchy's residue theorem. Okay. Second type is evaluate integral 0 to infinity dx divided by x square plus a square whole cube. Here you have to just put, okay, x equal to z. just put x equal to z. So if you are putting x equal to z, then C is the contour made up of upper half of the semicircle taken in the anti-clockwise direction and the line segment minus r to plus r. See here, in this type of problem, you will have the contour as upper half of the semicircle. Okay, semicircle radiuses are here. Okay, so upper half of the semicircle. Okay, and the real line you are going to consider. So you have to consider the points which are lying inside this contour, upper semicircle. Okay, therefore here in this problem, by taking x equal to z, you will get z square plus a square whole power 3. Then dx will become dz. The contour is upper half of the semicircle and the real line. So here this 0 to 0 to infinity will become what? You will have upper half of the semicircle and the line, okay, x-axis. So mod z equal to r. Mod z equal to r. Here in this, what are the singular point lies inside? The problem is z square plus a square the whole cube. So equate it to 0. You will get z square plus a square equal to 0. This gives you z square equal to minus a square. Therefore, z equal to what? Plus or minus ai. Since the power of this z square plus a square is 3, you can call z equal to plus or minus ai is a pole of order 3. Okay, is a pole of order 3. Now, we have converted this problem into a complex variable. Therefore, by Cauchy's residue theorem, integral over C f of z into dz is 2 pi a into sum of the residues. We have to identify that this integral over C f of z into dz consists of what contour? Here the contour is upper semicircle and the real line, okay, minus r to plus r, which is equal to 2 pi I into sum of the residues. Here, to find out the residue, since it is a pole of order 3, you are going to have, what is the formula? 1 by n minus 1 factorial, limit z tends to ai, d power n minus 1 divided by dz power n minus 1 into z minus ai power n into f of z. See here, the point z equal to ai lies where? ai. Okay, z equal to ai referring the point x plus iy equal to ai. So x equal to 0, y equal to a. Therefore, it represents the point x comma y equal to 0 comma a. 0 comma a means x equal to 0 is the y axis. A point you can consider, okay, somewhere here. So 0 comma a lies inside the upper semicircle. What can you say about z equal to minus ai? Z equal to minus ai referring the point, okay, in the similar manner you have to consider x plus iy equal to minus ai. So it gives you the point 0 comma minus a. 0 comma minus a lies opposite, which is lies outside of the, okay, upper semicircle. Therefore, you are going to find out the residue at the point, okay, R1 you are going to find the residue of f of z at z equal to ai. It is a simple pole. Z equal to ai. is a simple pole, you know that. So because of that only, we are finding here R1 equal to 1 by n minus 1 factorial limit z tends to ai d power n minus 1 by dz power n minus 1 into z minus ai power n into f of z. What is n here? N is the order of the pole, n equal to 3. So you are having 1 by 2 factorial z tends to ai d square by dz square of z minus ai the whole cube into 1 by this term. Okay, here you are having z square plus a square the whole cube. This you can write it as z plus ai the whole cube into z minus ai the whole cube. So before differentiating it, you cancel the common term and then do the differentiation. Now, if you are doing the differentiation one time, you will get, okay, this you can write it as, if you are writing in the numerator, you will get it as z plus ai the whole power minus 3. So, differentiated minus 3 into z plus ai the whole power minus 4 into differentiation of z is 1. Again, we have to do the differentiation. So, we are going to get minus 3 into minus 4 into z plus ai the whole power minus 1 minus 5 into differentiation of z is 1. So minus 3 into minus 4 gives you 12 into z plus ai the whole power minus 5. Okay. So here 1 by 2 factorial is 1 by 2 itself. Limit z tends to ai. Okay. Substitute z equal to ai here. So you will get 2 times ai power minus 5. Here 12 and 2 gets cancelled. Here in 12 you are having 6 times 2 into 2ai power minus 5, that we can write it as, okay, 6 divided by 2 power 5 into ai power 5. 2 power 5 we know that it is 32, okay, so this is going to be 6 divided by 32 into, okay, a power 5 into I power 5. We know I square is equal to minus 1. So I square into I square into I. This I power 5, we are writing I square into I square into I. Now we know what is the value of I square. I square is minus 1. So minus 1 into minus 1 into I. This gives you plus I. I power 5 is plus I. Therefore, you are going to have, okay, 6 by 32 is 3, here 16 times. So 3 by 16 into, okay, a power 5 into I. Where we have to substitute? We have to substitute in this equation 1. Substituting in equation 1, okay, integral over the contour gamma. What is gamma? Gamma is, okay, mod z equal to r, f of z into dz plus integral over the line, that is real line, f of z into dz equal to 2 pi a into 3 by 16 a power 5 into I get cancelled and 2 also divide 16 8 times. Therefore, you are going to have 3 pi by 8 a power 5. Okay. So what happens? Here you are going to apply Jordan's lemma. When you are applying r tends to infinity, okay, when you are applying r tends to infinity, this contour, what is gamma here? Gamma is mod z equal to r. So when you are applying r tends to infinity, this contour will also become, okay, infinite radius. So in that case, gamma tends to 0. Gamma approaches 0. So this entire first part integration will become 0, and here in the place of r you are going to put infinity. So you are getting integral minus infinity to plus infinity. Okay, f of x into dx equal to 3 pi by 8a power 5. Okay, why we are putting x here? It is a real line. So by Cauchy's lemma, you are getting integral over gamma f of z into dz tends to 0. Therefore, integral minus infinity to plus infinity dx by x square plus a square the whole cube equal to 3 pi by 8 power 5. But in the problem you are having integral 0 to infinity. So this we can write it as twice of integral 0 to infinity dx divided by x square plus a square whole power 3, which is equal to 3 pi divided by 8a power 5. So bringing this 2 to the right hand side, we are getting 3 pi by 16a power 5. Hope you understood the second type. Now we'll see the similar problem. This is type 3. How it is different from type 2? If you are seeing the numerator, you are having x sin x. The numerator can be a function of sine and cos. So using the contour integration, evaluate integral 0 to infinity x sin x into dx divided by x square plus a square. You can have cos x also in the numerator. Now what is the transformation you are going to consider? This x you are going to replace it by z, and for sin x, okay, you are going to put e power ix. What is e power ix? It is cos x plus I sin x. So this term is imaginary part of e power ix is sin x. That we are going to use it here. Here also we are having the limit as 0 to infinity. So the contour is going to be the upper semicircle and the real line. Okay, this upper semicircle is evaluated in anti-clockwise direction. Now you are going to get, we are converting this integration in terms of the complex variable. After converting in terms of the complex variable, you have to solve it with the help of Cauchy's residue theorem. By applying Cauchy's residue theorem, you have to know the residues. To know the residues, you have to know what are the poles. For getting the poles, equating the denominator to 0, you are getting z square equal to minus a square. Therefore, this gives you z equal to plus or minus ai. What z equal to ai refers? We have seen it previously itself. It refers the point x comma y equal to 0 comma a. And what about z equal to minus ai refers? Z equal to minus ai refers the point x comma y equal to 0 comma minus a. So here the circle is upper semicircle, and the real line we are going to consider mod z equal to r and minus r to plus r. This is gamma. So by Cauchy's residue theorem, integral over c f of z into dz equal to 2 pi a into sum of the residues. Here you can easily observe that the point z equal to ai lies inside the contour 0 comma a, and the point z equal to minus ai lies outside the circle. It is below this upper semicircle. So the only point lies inside the contour is z equal to ai, and it is a simple pole. So by residue formula at simple pole, limit z tends to ai, z minus ai into f of z. What is f of z? Z into e power I z divided by z square plus a square. The z square plus a square we can write it as z plus ai into z minus ai. Now cancel the common term and then apply z tends to ai. This gives you ai into e power e power, okay, ai into I divided by 2 times of ai. So I square is minus 1. Therefore, you are going to have I gets cancelled, A also get cancelled. Okay, e power minus A divided by 2. Now substituting here, you will get 2 pi a into e power minus A divided by 2. So 2 gets cancelled. Then by Cauchy's lemma, when you are allowing r tends to infinity, this upper semicircle part gets tends to 0, and the second real line evaluation of the function, okay, will become pi I into e power minus a. So integral minus infinity to plus infinity f of x into dx equal to pi I into e power minus a. Now what is the problem given? Integral minus infinity to plus infinity x into e power ix divided by x square plus a square into dx equal to pi I into e power minus a. Now e power ix we can write it as cos x plus I sin x divided by x square plus a square into dx. We need the problem of x into sin x. Therefore, equating the imaginary part both sides, you will get x into sin x divided by x square plus a square. This integration over minus infinity to plus infinity into dx equal to pi into e power minus a. Okay, here the function is an even function. Since it is an even function, how it is even function? If I am putting, okay, f of minus x equal to f of x itself. Here the function is, you are having f of x equal to x sin x divided by x square plus a square. What is f of minus x? Minus x into sine of minus x divided by minus x the whole square plus a square. So we know sine of minus theta is minus sine theta. Therefore, x into sine x divided by x square plus a square, which is the original function f of x. Hence, f of x is an even function. If it is an even function, then integral minus a to plus a f of x into dx can be written as twice of integral 0 to a, okay, f of x into dx for even function. You can write it in this manner. Okay, because of that, you are getting this equal to twice of, okay, here twice of integral 0 to infinity x into sine x divided by x square plus a square into dx equal to pi into e power minus a. Therefore, bringing this to this side, right hand side, integral 0 to infinity x into sin x by x square plus a square into dx equal to pi by 2 into e power minus a. Hope you understood. This completes the evaluation of complex integration using Cauchy's integral theorem as well as Cauchy's residue theorem. And in this lecture, we have learned about how to solve the contour integration with the help of Cauchy's residue theorem. Thank you.